here we go. Net ionics. So when you get a paycheck, if you guys have started getting paychecks, you will notice that there are two different categories. You get paid a gross amount, but you only take home a net amount. So this is the amount that you can actually do something with. The rest of this goes out to taxes, Social Security, FICA, and then some of it gets shuttled over here, and that's what you get to, they call that your take-home pay. Okay, that's what you get to pay your rent with, your cell phone bills, all of that good stuff once you have to start paying for all that. So today we're going to be talking about a net ionic equation. What's actually reacting as opposed to what's staying in solution. Okay, so step one is you are going to write a balanced equation. And then I'll show you how to break out that for the reactants and aqueous products as ions. So we're going to start with sodium chromate. And we're going to have zinc sulfate. We're going to go through our double replacement reaction. And zinc chromate is going to form. We're going to balance the reaction, which is already balanced. Then we're going to go to our sheets. And we're going to find where sodium is. We're going to find where sulfate is. And when we find sodium and sulfate, it has a big honking S there, which means I'm going to write AQ here. Now, how did I do that quickly? Sodium's always soluble. Okay. There are 4 things that are always soluble. Sodium nitrate. So sodium is Na. Nitrates, ammonia, which is NH4 plus. These are minuses. This is a plus. And then potassium is the other one. So anytime you have these as one of your ions, they're always going to be soluble. So that's how I can do that very quickly. When you get into AP with me, you just remember that. These are the only 4 that you have to remember in AP. So that's why we give you that acronym. Okay. All right. So we know that's aqueous. Chromates are usually not, and that's found on the back side of your solubility table. Okay. So these are all over here aqueous. They're all floating around as ions. But this is the only thing that's actually going to change, because here, these are still going to be floating around as ions. So what I do is I take this and I find the ions over here that are going to support that. So I needed zinc. I'm going to put that as ions. I needed sulfate. I'm going to find the ions for that. These are aqueous before they're mixed together. Once we mix those 2 test tubes together, then we form this solid. And we don't include the sodium and the sulfate. Oh, wait, I should have chromate there. Hold on. Bad lippy. CrO4. Sorry. So I should have the zinc and the chromate here that form this. Iron 3 hydroxide. I don't have all of these memorized, you guys. Iron 3. Yep, it's going to form solid. All right. Lead sulfate. Potassium and sodium. All right, so here's one. We've got potassium chloride. We've got sodium nitrate. I swap partners. I form KNO3 and I form NaCl. I find that this is aqueous and that this is aqueous. What do? No reaction. Done.
So if they're both aqueous, there is no reaction.
Correct. Because nothing's changed.
Products are all aqueous. So no reaction.
Yep. All right. I want to do one more with you, and that's this one. This isn't one. Ends up being one of those special cases that we've talked about. K2CO3. This is going to form these two came from this. But remember, that breaks down into these two things. Okay? So I want to talk to you about how to do a net ionic in this way. So step one, we know that this is going to run because we're forming water, we're forming a gas. We know that this is aqueous because it contains potassium. So we don't even, if you get kind of used to that one, you know, that being part of that SNAC acronym, it makes it faster. You don't have to look it up as much. But you can have that table. You can look it up. It's fine. But just, if you notice potassium going all the way across, it's all S's. If you notice sodium, it's all S's. If you notice nitrate going all the way down, it's all, well, there's two nitrates there. That's mercury. We never use mercury anyway. It's deadly. All right. So that's where these two came from, is this guy. Okay. So now I need to balance this. I've got 3 of these over here. I've got 2 of these over here. I'm going to look for the least common multiple, which is between 2 and 3. 6. So I'm going to put a 3 here, and I'm going to put a 2 here, and that's going to get those to balance. That's going to give me 2 phosphates over here. So I got my phosphates taken care of now. Then I need 6 hydrogens. So I'm going to put a 3 here. And I'm going to need 3 carbons. So I'm going to put a 3 here, and then I'm going to check my oxygens. I should have 9 oxygens. I have 3 here and I have 6 there. Okay, so we're balanced. Now I need to do my net ionic. Anything that's aqueous is not going to show up in your net ionic because it's going to stay as ions. So anything that's not aqueous, I'm going to write down here. And then I'm going to find the ions over here that formed these. So I needed 6 hydrogens. So I'm going to go 2 times 3 is 6 H plus. And I needed 3 carbonates. It is always a good idea to make sure that your net ionic is balanced. So I have 6 hydrogens over here. I have 6 over here. No, it's an ion. So if it's an ion, you're not Brinkelhoffing it, okay? Because it's going to float around as an ion. This is, again, this is aqueous. So this is floating around in water as an H plus ion. And that's going to become important when we get into acids and bases, because this is actually what your pH is measured as. So you've heard of pH before? Your pH is the concentration, so how much of this stuff there is. And the lower the pH, the more of this stuff you have, which is counterintuitive. But I'll take you there. That's later this year. Okay. So this stuff here, everything on this side of a net ionic has to be as ions. So when you're doing a net ionic equation, you need to have ions for the ionic equation. So this whole side over here needs to be in the form of ions. So you should have charges on all of your reactants. And then the stuff over here shouldn't have charges, because it's going to be combined in some form. It's not going to be floating around as ions anymore. All right. Now, I'm not as picky on these as I am your regular equations, but you could at this point reduce this down. And that is truly what your net ionic equation is. Okay. But I wouldn't, if you're doing a net ionic, I usually don't ding you points on reduction. All right. Makes sense? Everybody cool with that? That's the end of chapter 9. Your test is next Friday. Okay. If we go and we look out at your schedule here, that's what's coming up. Here is unit 9. So next week we have a lab on Monday. Tuesday is your mastery prep. Don't think I have any seniors in here. Yeah. Then we're going to do a review on Wednesday. That is a shorter day because we have an author coming for a visit. Then we're going to do our review on Thursday. That is a shortened day because you have the math mastery prep during advisory. And then your test is here. That's why I wanted to make sure that you had a full day, a 47-minute period to do your test, as opposed to trying to cram it in one of these days, because I don't want to try to have to hassle with 38-minute classes or whatever it ends up being. So, but that's what we're looking at as far as kind of projecting ahead. Okay? Everybody good? So the remainder of your time today, you may spend either working on your homework for this weekend, or if you still have tests or quizzes that you need to correct and retake, you can use the remainder of the time to do that as well.